All right. So you're going to be grossly disappointed because I'm actually not going to talk about TensorFlow. Tom, who's going to coming after me, is going to talk about TensorFlow. I'm going to, talk about some of the interesting business challenges we face when utilizing some of these technologies. And actually, I'm going to talk more generally about AI. Everybody's going to, so you've all probably got different definitions of AI, I guess. And so I'm going to clarify what AI is. Does anybody know about Satalia, by the way? Just want to, my company. Okay, cool. We'll talk about AI. We'll talk about innovation, how we can use these technologies to do cool things, and we'll also talk about the end of the world as well. And so, which is always a nice topic. So I do three things actually. So the first thing I do is I run a master's program in UCL in their computer science department called Business Analytics. So I have 100 students every year, master's students that are learning about these technologies that you're going to be talking about today, and going out there into industry applying them. So I've got a good sense about where organizations are at in terms of their journey, what really is going on out there with the use of these technologies and where it might go as well. I do all of that for fun, and actually I'm going to be entrepreneur in residence for UCL as well, which means I get access to all of their resources and whatnot. But I have an evil corporate hat where I run a company called Satalia. Satalia is about 100 people distributed across Europe, and we build AI solutions for some of the biggest companies in the world. So we use these technologies also coupled with other technologies to build solutions for the likes of Tesco and PwC. And the third thing I do, which is why I'm here, is I do about 100 keynotes a year, usually actually to audiences a lot bigger than this, so probably about 1,000 people at a time. But I did a talk in Marbella with Nuno, who's the CEO of YLD. He was in the audience and he said, Daniel, why don't you come and do a talk at our meetup? I said, cool, I don't know anything about TensorFlow, so I'm just going to declare that from the outset. So we're going to get quite philosophical today, and I'd be very keen for you to challenge me on some of these ideas. All right, so let's go from here. So where is this? Actually, can I get a sense of actually who we've got in the audience? So who are practitioners who are actually building systems using TensorFlow? Don't be shy. I'm going to ask you lots of questions, by the way. You're going to have to respond. So one person. And so who's just came for the food? Yeah. So where else are you coming from? Who else? Why are you here? Why are we here?
So we are both wants to learn.
You want to learn?
He wants to learn. That's why we're
about TensorFlow?
Yeah.
Okay, so that's not me. That'll be Tom.
TensorFlow and also mainly the machine learning, what it is.
Oh, cool. I can cover that. What else do you want to know? Anybody else? What do you want to learn about today? I've got 20 years of experience in AI, so I'm happy to answer. We can go off piste if you want. Anything else that anybody particularly wants to learn about?
Where to start and what tools
cool.
you want to learn, how to step forward and where we want to take.
I'll cover all of that. It's no problem yet.
I'm in the process of designing a curriculum for beginners who aren't engineers.
Awesome.
Who want to know more about AI and machine learning.
Awesome. I'll totally nail that for you. I'll nail it for you, yeah.
I'll be looking at not a TensorFlow expert, but dabbled, I would say.
Yeah.
But the interest had been on taking models, porting them to embedded systems.
Okay.
So, like cameras and things like that.
Cool. That's interesting.
That's where my interest has been.
Very cool.
That's why I'm here.
Excellent. Anybody else wants to learn anything crazy? No? Okay, all right. So let's crack on. So, okay, so yeah, that's about me. So before we get into definitions of AI, which I'm sure, as I said, everybody has different definitions, which I'm going to clarify. I take you through this technology stack. And actually, this technology stack is probably good for you to understand for your curriculum, and it's good for anybody to understand where machine learning sits when building systems that solve problems in industry. And so actually, the first question that I want to ask you all is, what is data? What is data? Bits and bytes, yeah, good. A lot of people say information. You're absolutely right. So data comes from the Latin word datum, which means given things. It's ones and zeros, it's symbols, it's bits and bytes. It's the fabric of our universe. And it's not until you give it context does it become information. So if I say to you, 210-280, what is this? It's data. If I say that it's a date of birth or a sort code or how much money I have in my account, then it becomes information. By the way, I like to think that you're quite lucky today because I usually get paid £10,000 to do these talks. Genuinely, I do. I get to travel around the world, so yeah, you can Yeah, it doesn't matter. Anyway, let me ask you this question then. So what does this probably say? ABC, okay, good. What does this probably say? Okay, if you're normal, it probably says ABC. And if you're a developer, it probably says A13C. So what does this probably say?
1, 2, 1, 3.
Yeah, 12, 13, 14. But you can see that the data that's entering your eyes is stuff in the middle, the same data, but you're giving it a different meaning based on its context. And if I tweeted right now, my laptop is sick, what does that mean? My laptop is sick. It's cool, you're cool. Yeah, it probably means, well, for me it means it's broken because I'm old and boring. But that sound can be interpreted in two different ways. One, and how you interpret it, it really impacts your decision. All right, what does this say? What does that say? I know you can do this. John read the letter to Mary. Excellent. What else? John read the letter to Mary could be an instruction. I want you to picture in your mind the scene. John read the letter to Mary. John read the letter to Mary. What picture do you have in your head? John read the letter to Mary. It's obvious, isn't it? A guy reading a letter out loud to Mary. Anybody else have a different picture? John read the letter to Mary. John could be reading a letter that was sent to Mary or addressed to Mary. John could be reading the alphabet, A, B, C, D, to Mary. John could be reading the letter of the law to Mary. John could be reading a book called The Letter to Mary. John could be reading a book called The Letter to Mary. John could be reading 2 words on a piece of paper, The Letter to Mary. This can be interpreted in over 13 different ways, and we will all go away with a picture in our mind of what we think is correct, and we're probably wrong. And my goal in this talk is to convince you all that humans are rubbish. Okay, that's my goal today. And actually one of the biggest challenges we have in computer science and how we can use these technologies like TensorFlow is to try to take all of this stuff, all of this data, and try to figure out what does it actually mean. Yeah? Does it mean positive? Does it mean negative? What does it actually mean? Because knowing what it means then determines the decisions that you make. All right, so imagine if I give you a spreadsheet, and in the spreadsheet it has 3 columns. It has a column which is a date, a column which is a temperature, and a column which is the ice creams that I sold on that date. Date, temperature, ice cream sales. What do you do with that spreadsheet? What do you do with that data? Date, temperature, ice cream sales. I know you can do this. Huh?
You can predict how many ice creams sold.
Okay, so let's draw a graph. So we've got increase in temperature along this axis. We've got increase in ice cream sales along this axis. What would my graph look like? I know you can do this. Huh? You would see some sort of trend going upwards, right? The hotter it gets, the more ice creams I sell. This is called...
It's the temperature of the ice cream itself.
That's true. But in this case, it's the temperature outside. So we can do... This is called descriptive analytics. What we're doing is we're taking information and we're organising it in a way to find patterns. Right? This is what I would argue that knowledge is. And we can do something really cool now, which is, I guess, what you're excited about, what industry is excited about. We can do a thing called predictive analytics, and we can put a line through it. Okay? So now we have predictive power. So if it's 22 degrees outside, what we need to do is we need to look at our model and see how many ice creams I need to manufacture. So your line is your simplest predictive model. And I guess all machine learning is trying to do is to fit some sort of line or plane or hyperplane to some set of data. That's all machine learning is really trying to do. And the more complex the data, typically the more complex the machine learning techniques that you need. So now what I can do is I can take my model, my predictive model, I can put it into a factory. I can have my factory now manufacturing ice creams based on this model. But knowing something is very different to understanding it. Can anybody tell me why we sell ice creams when it's hot outside? Why do we sell ice creams when it's hot outside? Not a trick question. I'm inside, it's hot outside. What's the first thing that usually happens in the UK? We go outside. And why do we go outside? We like the sun, we get vitamin D, then what happens? Scarce resource, what happens? We get too hot, then what happens? We buy an ice cream, what happens to the ice cream? Put it down our pants, what do we do with the ice cream? Huh? Eat it. And why does eating an ice cream cool you down? It's cold, exactly. Thermodynamics. To expect a computer to understand that narrative from this line is impossible. It's not going to understand that humans like to get vitamin D and we cool ourselves down in lots of ways. So it's important to be able to bridge the domain experts, the people that can interpret those patterns, with the people that can find the patterns. So I'd argue that we can use machine learning, these techniques, to elicit knowledge, elicit patterns from data, but we need people to be able to interpret them. And it's really super important that you as a data scientist or whatever don't try and necessarily interpret them yourself because you might be wrong. And actually your domain expert's going to say, Daniel, your model of the world is wrong. Because if I put this into a factory and the tomorrow is the hottest day ever, scorching hot, what will my factory do? What will my factory do? It's going to manufacture lots of ice creams, but what will really happen if tomorrow is the hottest day ever, scorching hot? Everybody's going to stay inside because they can't reach an ice cream fast enough. So your model of the world is wrong, and actually the model of the world looks more like this. This is why it's really important to bridge the domain expert with the people that are good at finding patterns. But once you understand the world perfectly, ultimately you want to use that understanding to be able to make decisions. And decision making is actually a whole realm of computer science that you might not be aware of, but typically humans do this bit, and humans are terrible at decision making. Let me try to argue this. Has anybody read the book Thinking Fast and Slow by Daniel Kahneman? Highly recommend you read this book. Daniel Kahneman is a Nobel Prize winning economist, and he argues that we have a fast brain and a slow brain. All right, so I'm going to ask you some maths questions. Your job is to answer these maths questions as fast as possible, all right? So the first question is, what is 2 times 2? Good. What is 14 times 763? All right, so that's your slow brain. The first one was your fast brain. And sometimes your slow brain gets it right, sometimes it gets wrong, etc. Let me ask you this. What colour is this? I don't know if you can see it actually. What colour is this?
Hello.
Yellowish. What colour is this? Brownish. Actually, it's the same colour, right? I promise you right now, the same coloured light is going into your eyes, but you're giving it a different perception based on how your brain works, your statistical experience. No matter how long you look at this, your fast brain will always perceive them as being different colours. And if I asked you this, what colour, I always get this wrong, what colour is this?
Blue.
Good. What colour is this?
Yellow.
Good. They're all grey. Right, I promise you right now, grey light is going into your eyes and you're perceiving them as different colours. And I'm not going to ask you to do this, but if you held your thumbnail in front of you, the size of your colour vision is about the size of your thumbnail. So all of this colour that you see in your periphery is being made up by your brain. Your brain is making up a huge amount of the world based on its experience, and very often it gets it wrong. And you have to understand that all a machine learning model essentially operates the same. And I'll talk about this later on. It has a statistical experience, which we'll talk about later on. Anyway, I'm going to ask you some more maths questions. The next math question is the combined price of a bat and a ball is £1 and 10 pence. The bat is £1 more than the ball. How much is the ball?
5 pence.
5 pence? You knew the answer already, didn't you? Cheat. So if you thought 10 pence, don't worry, you're not broken. You're just biased. That was using your fast brain. And I can give you thousands of these questions and you will get them wrong. Even you will get them wrong. The bat is £1 and 5 pence. The ball is 5 pence. The combined price is £1 and 10 pence. And okay, let me ask you this. So imagine these are staff members, let's say. Okay, or developers, I don't know what. And we know everything about these staff members. We know their skills, we know whether they can fly or swim and all this kind of stuff. I'm not going to ask you to do this, but if we wanted to organise these staff members in a way that satisfies some rules. So, for example, you're not allowed to have the same 2 coloured staff members touching, and males prefer to be near females, and flying staff members have got to be the right of walking ones. Can anybody tell me how many possible combinations there are of these 5 staff members? So I'm looking at one combination, I can flip 2 around, I get another combination, flip another 2 around, another combination. How many possible combinations are there? 5 factorial, yeah, exactly. 5 times 4 times 3 times 2 times 1. So there's 120 possible combinations. Some will satisfy the rules, many won't. One will be the best one. Let's make the problem a bit more complicated. How many possible combinations with 15? Don't say 15 factorial. How many possible combinations? What does your fast brain say? Guess. Nearest one is the winner. Huh? Guess?
10 million.
10 million? Okay, so there's over 1 trillion possible combinations of staff members. You won, by the way, you were the closest. And to expect a human to solve this problem is wasting your time. Anything more than 7, don't use a human for. Any allocation of resources, whether you're trying to figure out how to spend marketing money, you're trying to figure out how to allocate your staff, anything more than 7, humans are pretty useless. And actually, industry don't have problems of this size, they have problems of this size. There are 500 Pokemon. Can anybody tell me how many possible combinations? No, it's a big number. It's a number that's this big, and just put this number into context, this is how many atoms there are in the universe. So, and maybe just to put this number into context, one of my clients is a large consultancy. They have 5,000 staff they need to allocate to projects. 5,000 factorial, which is a number you can't even imagine. You can't even imagine that number. But, and they've got people trying to solve this problem, wasting their time. Anything more than 7, don't use a human for. Let's just run this problem home. So imagine I've got my ice cream van, and my ice cream van has to deliver packages, ice creams around London. If I wanted to draw a path around these 24 points that saves me the most amount of petrol, after probably 5 minutes, I'd probably get quite a nice path around those points. How long will it take a computer to get the best path, the shortest path? Huh? Seconds? Okay, we played this game already. It's actually 20 billion years. So if you put 24 times 23 times 22 times 21 into your calculator, you have got this number of possible routes. And if you had a computer, if you did a dumb way of solving this, if you had a computer that could look at 1 million routes a second, that could process 1 million routes a second, it would take 20 billion years to go through every single possible one and say, this one that I looked at 10 billion years ago, this one's the shortest one. And if I had another point to the map, I get now 25 times 20 billion years, 5,000 billion years. If I had another point to the map, I've got now 26 times 5,000 billion years. These are exponential problems. And any allocation of resources is probably an exponential problem. And again, companies don't have problems of this size. Tesco is one of our clients. They've got 100,000 points on a map we have to deliver to, 100,000 points on the map. And they've got, yeah. So this is why algorithms are important, and I want to demystify a few things. So when my company builds systems for companies, they usually have these 3 parts. So they've got the data part, and everybody's going on their digital transformation to try and pull all of their data together, make sure it's all in one place. Everybody, including probably you guys, are excited about this part, which is, can we use TensorFlow, machine learning techniques, statistics to try and find patterns from data? This is where your data scientists sit. But I would argue that this is only half the journey. Ultimately, you need to know things about the world. You need to know you're male, you're female, you're happy, you're sad, and then you need to be able to make decisions with that knowledge. So these technologies that we're talking about today, really good at knowing things about the world, but they're not good at making decisions. This is a completely different set of skills, decision making. I think that these are going to be the next data scientists. They used to be called operations researchers 20 years ago. That kind of matured in academia. Everybody started to get excited about this bit. But I think that this bit's going to then start to plateau, and organizations are going to realize that this is where the real skills are needed. And so actually you need to combine both of these, but I would argue that there are only about 3,000 strong optimization experts around the globe, 3,000. So, and I would also argue that companies don't really have machine learning problems. They have decision problems, and decision making tends to be in this realm. The challenge is how you bring these three types of technology together. Now, if you build a system that you give data to and it makes a decision, and tomorrow you give it the same data, it makes the same decision, you have automation. And automation can drive a lot of value in your company, because this can do stuff better than humans, and this can definitely do stuff better than humans. But if you have a system that makes the same decision today than it does tomorrow, you have automation. And what's the definition of stupidity? Doing the same thing over again and expecting a different answer. So if you do manage to build a system that does this, then ultimately what you have is a system that is still stupid, and by definition it is not intelligent. Everybody that touches this technology stack at the moment is calling themselves an AI company, and I know that you get more money from VCs and you get more money from clients if you call yourselves an AI company, but for me this is not AI. Right, there are 2 definitions of AI. So I did my PhD in this, and the first definition I think is weak but popular, which is getting computers to do things that humans can do. Right? The reason why this is popular is because humans are the most intelligent thing that we know in the universe. And when we start to get machines to do things that are traditionally only in the domain of human beings, and we start to get machines to do things like corresponding natural language and recognize objects and images, stuff like this, when we start to get machines to do that, we then attribute that to be intelligent, because we think that humans are intelligent. I would argue that humans are very good at finding patterns in about 4 dimensions. We're very good at solving problems up to about 7. Computers can find patterns in thousands of dimensions. They can solve problems with thousands of moving parts. Benchmarking machine intelligence against human intelligence is a very silly thing to do. Okay, and the reason why, I'll talk a bit more about this later on, but actually there's a better definition of AI that comes from the definition of intelligence, which is, for me, a really elegant definition, which is goal-directed adaptive behavior. Goal-directed in the sense you're trying to achieve an objective. You're trying to sell as many ice creams as possible. You're trying to allocate your resources efficiently as possible. You have to have an objective. Behavior is how quickly can I achieve that objective? How quickly can I allocate my resources to achieve that objective? But I would argue that your system is only AI if it makes a decision, learns about whether that decision is good or bad, adapts its own internal understanding of the world so that tomorrow it makes a better decision. Ultimately, for me, a true AI system is a system that is able to adapt itself in production. So online learning and stuff like that. And I would argue I haven't seen a single successful, complex adaptive system yet in my life. So there are some companies that are using recommender systems that are adapting themselves, but I would argue that recommender systems are relatively simple systems. But for me, the true paradigm of AI are systems that are able to adapt in milliseconds as opposed to months or weeks or years, which usually happens. And does anybody remember the Microsoft Twitter bot that became sexist and racist very quickly? So Microsoft launched a Twitter bot a few years ago. Lots of teenagers decided to start teasing it, and it became a Nazi bot very quickly. And this is what happens when you put systems in production that adapt themselves. They can adapt in ways you can't predict. And so I would argue that building a system that combines these three things is hard enough. It's complex, it takes years, but then building it in a way that can adapt safely is 10 times more complicated, which is why we don't currently see them. Because if you say to an IT director, we're going to put a system that's in place that's going to behave differently today than it is tomorrow, they say, no way is that going into production, because I've got all of these other services that are dependent upon it. And the second thing is you say, I'm going to put a system in production, and for it to get better, it needs to make mistakes. And there's no way that somebody's going to want to put systems in production that make mistakes, that have to learn. Even though I would argue that this is always make a mistake, it's always getting things wrong. Okay. So there are two flavors of AI. So this is one of my favorite paintings, is Socrates before he drinks hemlock and kills himself. And Socrates is famous for inspiring the Socratic method. So if I say to you, Socrates is a man and all men are mortal, what can I infer from that? I can infer that Socrates is mortal. And so AI in the 60s and 70s was us writing down lots of rules like this, and then trying to infer new knowledge from those rules. And it didn't really scale, so there was an AI winter. And then in the 70s and 80s, a new type of AI came along called neural networks. And this is the brain of a bumblebee. Bumblebees have 1 million neurons. My PhD 12 years ago was trying to model the brain of a bumblebee. Bumblebees' brains can fit on the end of a needle. And they can do amazing things. They can fly around 3D worlds. They experience the same optical illusions that humans do. They talk to each other. They solve problems. They don't handle windows very well, but ultimately, they're very smart little creatures. And the question was, can you take the brain of a bumblebee and can you model it in a machine? And 12 years ago, it was impossible. And but 8 years ago, because of new advances in neural networks, deep learning, all of this kind of stuff, the stuff that TensorFlow now does, we can now build brains that have hundreds of millions of neurons. And we can now get these things, we can train these things to do things that are traditionally only in the domain of human beings, like recognize whether people are happy or sad, corresponding natural language. But I would argue these brains are really good at finding patterns in data. You would not use these brains to make decisions. Make complex decisions. What you want to do is you want to use these brains to know things about the world, and then you want to then use these technologies to be able to then reason with that knowledge to be able to achieve some objective. And then you want to build a system that's able to adapt itself. Right? That, for me, is the true paradigm of AI. All right, this is where it gets a bit weird. So if this is the bounds of human ability, I would argue that we could probably take any task, whether it's a machine learning task or a decision task, and we can outperform a human at any specific task, very specific task. We can build a system that significantly outperforms a human. But it's very inefficient and costly to build individual systems that solve individual problems. It's a pain. And so there's lots of research in academia and industry in what is called AGI, artificial general intelligence. You are all AGI. You are one system that can do many things, and that's why humans are special. We are very, very good at adapting to many, many things. And the question is, can we build one brain that can do many things? And what's interesting is if you take this to its extreme, then it's predicted that within our lifetime, and I'm sure that you've all heard of this, we're going to build a brain that is smarter than us in every single possible way. This is often referred to as a singularity or superintelligence. This is the last invention that humanity will create, and nobody knows if it's going to be the most glorious thing that happens to us or our biggest existential threat. And I think it's our biggest existential threat, and the purpose of my company, of Satalia, is to try to figure out how to solve this. So actually, if you ask Elon Musk and other people like this, and again, I'm sure you've all heard of this, then they'll say, actually, this has already happened. We've already built a superintelligence. Because if you look at the size and the age of the universe is 14 billion years old, and the likelihood of there being intelligent life in our universe is mathematically very high. The likelihood of that intelligent life reaching a point where it builds a superintelligence is also mathematically very high. And if you build a superintelligence that can understand space and physics and time and all this kind of stuff infinitely better than a biological system, then when we look into the night sky, we should see a universe teeming with life. We should see evidence of life. And there's a concept called the Fermi paradox, which is actually that we don't see any evidence of life, even though we should. And the hypothesis is that we're living in a simulation created by a superintelligence in a different universe. which is often referred to as simulation theory, and there's a 1 in a billion chance that this is not a simulation. Is that not interesting? Keeps me awake at night, there's some interesting experiments in quantum physics that actually do indicate that this is a simulation. Anyway, before we build systems that make super intelligent, we're having to build systems. And when you build systems in TensorFlow or whatever technologies you're building, you're going to have to build systems that ultimately make decisions about people's lives. And you've all heard of this problem before. It's called the trolley problem. So I'm in my driverless car. In front of me is the kid. To the right are 2 adults, and to the left is a cliff. And the car can't stop. Who does the car kill? So who would kill the kid? Nobody. Who would kill the 2 adults? 1 person. Who would kill you? 1 person. It's not an easy question to answer, is it? And for 3,000 years, philosophers have been debating and pontificating about this stuff, and they still can't answer it. And the reason why they can't answer it, I would argue, is because we haven't agreed as a species what our objective is. What is our objective function? Well, actually, you could argue that the objective function is GDP. It's a stupid objective function. Don't get me started. And I think that we need to rethink our objective function for humanity. And we can talk about that. So if you're in India, I assume where are you from, sorry? India? India. Okay, so if you've got a cow and a dog in front of you, what do you kill? Cows are sacred, so you shouldn't. And if you're in the UK, small cow and a dog, you probably kill the cow. So even the culture will determine what decision you make. And I actually heard we'll have an ethical setting in our car where we say when we kill grandmas over cats and stuff like that. So the decision is pushed to us. And maybe actually one day we'll also create a digital twin of ourselves, an avatar that we teach about our preferences and this kind of stuff, and that avatar will be making decisions on our behalf. And just to give you an extension to this, I heard that maybe that avatar means that we could replace politicians. So at the moment what we do is we vote on a politician that represents us and our beliefs, and maybe they represent only 60% of what we believe. And instead of having politicians, when a new policy comes along, instead of us voting on it, because we don't have time to vote on thousands of policies, our avatar votes on it. And actually your avatar might even know you better than you know yourself, which I think is quite an interesting paradigm. So let me ask you this. So if you've got a building, a burning building, and in the building there's a crying baby and a suitcase with £1 billion, what do you save? You're going to save 1 crying baby or baby. And how many babies can you save with £1 billion? Lots of babies. And so if you build a machine, if you build a robot, and however that robot's brain is operating, and you say to the goal of your objective function is to maximize life expectancy. Seems like a reasonable goal. And maximizing life expectancy might mean going to invest that £1 billion in curing malaria. And you all know the answer to this, but if I build a machine and say your objective function is to eradicate cancer, what is the easiest way of eradicating cancer? Eradicating humanity, exactly. So we have to be very careful when we're building systems, whether they are machine learning systems, which are actually quite difficult to explain. So these machines tend to be black boxes, although there are lots of research that are trying to figure out how to make explainable machine learning algorithms. When you build these systems, ultimately people are trying to figure out who are accountable. We need to be able to explain how they're making their decisions. And just to give you some light at the end of the tunnel, machine learning algorithms tend to be very difficult to explain. Decision algorithms, so optimization algorithms, tend to be much easier to explain. And I would argue that organizations have optimization problems. They don't have machine learning problems. So there's a lot of papers coming out about explainable AI and safety AI. And I think that everybody has this myopic view that AI is about machine learning, and it's not. It's much more complex than that. And as I said, that most organizations have optimization problems, and that's a whole different realm. So if you ever read anything about AI and they don't mention about optimization, they really don't know what they're talking about. They know about machine learning, but not AI. Okay, so I'm going to just switch slightly. I'm going to talk about innovation, actually, which is an interesting topic for me. So I don't know if anybody's ever worked in a company before, but this is a traditional hierarchy, and traditional hierarchies breed certain types of relationships. This is not a picture of Satalia, although most people do sell drugs to each other. That's very popular in my company. If the definition of intelligence is goal-directed adaptive behavior, for your company to be more intelligent than another one, I would argue that company needs to be adaptable. It needs to be able to innovate. And I would argue that this technology stack that I just described will be a commodity in the next 10 years. So we already have access to cheap compute. You can all fire up thousands of computers dead cheaply. We already have access to tons of data. All of the tools that you need, TensorFlow is free. It's all free. You don't need to buy any of it. It's free. And at some point, somebody will commoditize optimization. Somebody will commoditize the adaptive part. The big battleground for organizations, and this might be important for you that are starting out at the beginning of your careers, is not technology, it's talent. How do you attract, motivate, retain talent to use these technologies to innovate? Because if your organization is not innovating, if it's not adapting to a changing world faster than another, then it is less intelligent. And actually, Steve Jobs gave a great definition of innovation. He said, innovation is creativity that ships. And the most important word in that definition is the word that. That is the process of taking ideas and getting them to the point where somebody's willing to pay for them. And if you're any entrepreneurs out there, an entrepreneur embodies that process. They have an idea and they need to get to the point where that idea is sustainable. And that process is long and hard and painful. The challenge is, how do you shorten that process? You shorten that process through accessing, motivating talent. People like you. And there's a very good introductory book on motivation by Dan Pink. He said there are 3 things that motivate people: autonomy, mastery, and purpose. Autonomy is giving people the freedom to do whatever they want, and mastery is giving them the ability to become really good at what they want. And it's great to see you all here trying to learn about new technologies, but probably most important is a purpose. Right? The youngsters nowadays, they want to make sure that they're not just helping Google or whoever make money, they're wanting to contribute positively to humanity. I think that it's super important for organizations, if you're starting out with your own companies, if you're thinking about joining companies, to have a strong purpose. And I'll talk more about this in a bit. The first challenge, I work with lots of companies that want to try to build out their own AI teams or whatever. And I often ask them, how sexy is your brand or your industry? And how interesting or challenging are your problems? Because if you're not sexy and you don't have interesting problems, you're not going to attract talent. And if you're sexy and you've got interesting problems, you'll attract talent and they will stick. And if you're in the other 2 quadrants, you'll attract talent and they will leave after a few years. And that can be more painful to your organization than not being able to attract talent at all. So it's really important that you're honest with yourself. A number of CEOs, global CEOs, that give loads of money to their CIO and say, go and build an AI team. And they can't hire a single person because they're deficient in this thing. So once you have attracted talent in one way or the other, you need to create a culture that enables that talent to thrive. Right? And over the past several decades, maybe some of you will know this, some of you won't, but we've seen a flattening of organizations, the removal of middle managers because of new technologies allow us to communicate and things like that. I think that this is still broken. So I have an aspiration, I have an ambition to use technologies like TensorFlow and machine learning AI to completely reinvent how an organization operates. Yes?
Sorry, can you just go back to the previous slide?
Yeah, could you want to take a picture? Yeah, you can have the slides if you want, it's fine. So I've got 100 people in Italia. So I've not taken venture capital because I don't like VCs very much. And I am trying to create a company that has no managers, no hierarchies, no KPIs. Everybody in Italia is completely free to do whatever they want. They can work wherever they want, on whatever they want, however they want. I'm trying to create a company that operates like a swarm and as opposed to a hierarchy. And the reason why this I think is interesting is because we can use technology like these technologies that we've mentioned to profile people, to understand the relationships between people, to help people with their learning and development, as opposed to having managers, as opposed to having these types of structures. And let me give you an example. Every year we ask everybody to make a public recommendation for their salary. So you would all publicly declare what you want to be paid. And then everybody votes on whether those salaries should be reduced or increased or kept the same. And we use machine learning to look at your data, to profile you based on how closely have you worked with that person, how knowledgeable about that domain, so that will give you more of a weighting than somebody else. So we use machine learning to determine the weighting, in this particular case, for voting on people's salaries. And so I had interns voting on my salary, and I had interns voting on other people's salaries who had a higher weighting than me. And so can we reinvent how an organization operates using these technologies to decentralize decision making? Because at the moment, lots of money is being invested in selling more shit to people, if I was being really honest, like profiling customers and all this kind of stuff. And also AI is being used to optimize your operations, which usually means firing people because it's cheaper. But I would argue that if you're not investing in these technologies to reinvent how your organization operates, you're probably dying from the inside. Okay, you're losing talent and you won't be able to replace that talent. Yes?
Are you basically talking about data science for people operations?
Both, because I think actually they're very, very interactive. They're intertwined. So you missed the beginning of the talk, but it's really important that the data scientists define the patterns, but the domain experts, the people operations, are able to interpret and understand those patterns. So we have people operational people that are PhDs in organizational psychology and stuff like that. Does that make sense? Because you can build systems like this just for the sake of using technology, but I wasn't going to talk about this, but I'd recommend everybody go and learn about a psychological thing called attachment theory. Has anybody got a therapist? I've got a therapist. No? Anyway, if you get a therapist, you'll learn about attachment theory, which is your upbringing as an infant, before you're even conscious, will affect your relationship styles as an adult. So apparently 60% of the population essentially are dysfunctional. You have attachment disorders. 60% have attachment disorder, which means that you are not stable in the way that you maintain, form relationships. And if you have these types of structures where your dignity is being threatened through imbalances in power, of course you're going to fight and you're going to flight in ways that are not stable. And so these for me are not conducive for the human condition, and I'm trying to design a system that takes into account these psychological things. And I'm going to tell it, not a secret, but my goal is to scale this to a planet. I want to try and create a completely decentralized planet where anybody is free to work wherever they want, however they want, and whatever they want, and remunerated fairly for that contribution. And if you can do that, then we might not need to have companies anymore, and we might not need to have countries. So my goal over the next 30 years is to remove the concept of companies and countries from this planet. And I'm happy to elaborate on that if you want. But before getting to that, what organizations are trying to do is they're going on their digital transformation, which means getting all of their data together. But what they're trying to do ultimately is create a digital twin of themselves. You might not have heard this term, but a digital twin is essentially, ironically, a simulation of your organization. It's a simulation of all of your physical assets, your machines, your vehicles, the health of them. It's even a simulation of your people. So this is not a ring, this is a device that's capturing my temperature, my heart rate, my location, and ultimately my organization is not machines, it's people. This is a digital twin of my company. These are optimization experts, software developers, data scientists, and I can see if one of those people leave, they're going to have a silo. I can see who might be leaving the organization. I can identify secret lovers in the company as well. So this also raises lots of ethical questions. So if I know that he's going to leave before he even knows he's going to leave, should I have that ability? And again, TensorFlow, these machine learning techniques can identify these patterns much, much better than human beings. Lots of very interesting ethical questions, but ultimately organizations are trying to create a digital twin that if they say we're going to spend more money on marketing over here, what impact will that have on the health of the organization, my supply chain, all of this kind of stuff. That's where organizations are going. I won't bore you with any of that. Interesting outcome from our pay review, which might be interesting for you. Lots of concern about bias, but imagine these dots are everybody in my company. One of our females, or actually a number of our females, made recommendations for their salary where they're clearly undervaluing themselves, which is a very common problem with females. So this blue dot's one of our females. She had 429 votes to approve her salary, 36 votes to reduce her salary, 280 votes to increase. So out of everybody in the company, she had the most votes to increase her salary. So she went away, she came back with a new recommendation, 500 votes almost to approve her salary, 0 votes to reduce, 210 votes to increase her salary. So still, she was undervaluing herself. And that was me on the end. They were saying, Daniel, you're undervaluing yourself, you need to pay yourself more. And so the question is, can you augment machine intelligence, in this case, understanding how many votes one person should have for another, with human intelligence, i.e. should that person's salary increase or decrease, and to make better decisions? In this case, you can. And you can use this model to make decisions about salary, around feedback, around what projects should work on, without having to have hierarchical structures. And again, the goal is to scale this to a planet. That's boring. I'm sure I'll talk about the end of the world now. So I'm sure you've all heard, you've seen Black Mirror, the Netflix. If you haven't watched Black Mirror, I'd highly recommend it. There's one episode called Nosedive. And Nosedive is it's essentially a dystopian future where all of us are rating each other. You'd be rating me out of 5 and I'd be rating you back out of 5. And what it does is it creates a social score. And that social score then unlocks faster internet and better hotel rooms and all this crap. And the point is that this is happening in China now. China are implementing a social score. We think it won't happen in the West. It will. I'm talking to governments. I'm talking to companies that are going to be rolling out these techniques. And my concern is that the people that decide on that score, the people that say, if you do this, your score increases, they're the people that control our population. And I genuinely think that we are sleepwalking into a dystopian future, because actually the goal of a company, the goal of a country is to maximize profit, is to maximize GDP. And ultimately, this will be a mechanism to squeeze more and more resource, more out of our people. And that is worrying. And let me ask you a quick question. What's Facebook's primary objective? What's their primary goal? Make money. Make money, exactly. So, and how do they make money? The longer you look at that screen, the more money Facebook makes. And they've got 10,000 PhDs whose job it is to keep you looking at that screen. And if Mark doesn't provide his 5% returns to his shareholders every quarter, he'll be replaced by somebody that will. And if you can't create your 5% returns through growth, through innovation, through new ideas, then what happens is that people tend to make bad decisions. They make decisions that compromise their users, that compromise their employees, compromise the environment. And this is the problem with this short-term 5% return attitude. We are creating an unsustainable future for our planet. And these technologies that we're using are going to become much better at hacking people, at knowing you better than you know yourself, selling you shit that you don't need. And so when you go out there and you work in companies, you need to be thinking very carefully about how you're applying these technologies, because these technologies are incredibly powerful. And which is why purpose is important, and I'll talk about this in a second. Actually, I would argue that maybe Facebook in the next 10 years might disappear. If you can create a platform where anybody can boot up an idea, let's say somebody can boot up an open source version of Facebook, and if you can unlock a global community of developers and designers and HR experts and whatever to drive forwards, to contribute that to that idea and drive it forwards, then I would argue you don't need to have a centralized company anymore. Facebook have 2 billion users, and if each user paid 10 pence per year, that's 200 million pounds of revenues. To access an open service, an open free, essentially a service whose motive is to connect people as opposed to making Mark Zuckerberg more money. And if somebody can crack this model that can bring all of these different skills together, then we might see companies like Facebook, Airbnb, Uber, all this kind of stuff disappear and be replaced by decentralized companies. And that's partly my goal. And I would argue that if you're a company sitting on IP, you might even want to consider decentralizing yourself. So I'm going to close now, sorry, which is there's 2 things I'm concerned about, and there's 2 things I think you should all be concerned about and thinking about, which is the use of these technologies will remove tasks. And it is removing tasks. And it's freeing people up to enable them to do more interesting things. But at some point, it will remove whole jobs. And at some point, you won't be able to retrain fast enough to get a new job because an AI will have replaced it. And it's different to historical industrial revolutions, because now we can create AIs that replace all jobs. And the concern is in the next 15 years, we're going to see a lot of job losses, and our economies are not set up to deal with this. And I sit on a number of think tanks, including with the author of this, that are concerned about this thing. The second thing I'm concerned about is this thing called the technological singularity, where we build a superintelligence smarter than us in every single possible way. It will be the last invention we create, and my concern is that if we are still fighting over GDP and resources by the time this thing comes, it's going to see us as a threat and remove us from the equation. And I think that over the next 30 years, we need to get humanity cooperating as a global species towards a common goal, as opposed to fighting each other for GDP. And I think that we should all be trying to solve that. And so just to close, the purpose of my company is to enable everybody to do what they love. How can we create a world where everybody has the ability to do stuff where they might not necessarily need to be paid, but are able to live without having to be paid? And I'm going to close there, actually. I'm open for questions.